Hello students, today we are in lecture 5, chapter 1 of electrostatics. We have studied so far the questions based on principle of superposition. Principle of superposition gives the idea to find the net force due to multiple charges acting on a charge. Today we'll solve few more interesting questions which are important for the board as well as competition. So here the first example. Suppose students, we are having the two charges. Okay, here the charge plus q and this is also plus q and the separation is r. I'm having the another charge q3 as minus q. So very simple. If I'll ask, where should I place this third charge so that it experiences net force 0? The answer will be in between these two charges at center. It will experience 0 force. Am I right? It will attract toward this force and it will attract toward this force also. And the magnitude of force will be equal and opposite, so it will cancel out and the net force will be how much? It is 0. On the basis of this concept, I am asking you this question. Okay, the two charges we are having here, the q and minus 4q, separated by distance r. Third charge q3 is minus q. Now the question, where should be third charge q3 of value minus q placed on lines joining these two charges, say A and B, so that it experiences net force 0? You have to find the position. Find the position so that force on q3 will be 0. Which force? Net force. Net force on q3 will be 0. If you can solve, then try to find out the answer. Okay students, let me solve this question. If we put this minus q in between these two charges, suppose I placed minus q, what will happen? This is plus and this is minus. This minus will move toward this one and this minus will repel in this direction. Here the two forces we are having, but both are in same direction, so net force will never be 0. So we cannot place this negative charge in between these two charges. Now placed out of this first charge over here minus. Okay, now this minus and plus, it will attract, and this minus and this minus, it will repel. So might be we'll have the net force as 0. Okay, but one can say, sir, we can place this negative charge over here also. How? This is minus, 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 repel each other. Very good. And this minus and this plus will attract each other. Now again we are having the two forces in opposite direction. Why not, sir? This two will cancel out each other. Of course, it might cancel out each other. But now we have to focus over the magnitude also. This two should be in opposite direction but equal in magnitude. Here both the forces are equal in magnitude. Now the force, you write here, it is k q1 q2 by r square. That is, it is directly proportional to the magnitude of product inversely proportional to the square of separation. If the separation will be smaller, force will be larger. Here the separation is smaller, so the force will be larger. Even separation is smaller, force increasing. But magnitude 4q and q, here the third charge is q. So 4q and q will give you the greater magnitude. Here separation of course is smaller, so it will increase the magnitude of force, but here the magnitude of charges are less, so the force will less, and here the separation will decrease, so the force will be enormously changed. So we cannot place this negative charge over here. And bear in your mind, whenever you will have the charge, whatever may be the nature of charge, plus or minus, if these two charges are opposite in nature, you cannot place this charge in between these two charges. If these two charges are opposite in nature, you cannot place the charge in between these two charges. First and second thing, you have to bear in your mind that you have to place this charge near the charge of smaller magnitude. Here the smaller magnitude charge is q. You cannot place this charge near the 4q. So you have to put this charge near the q. Here you will place the charge q over here. Now here the product is q square, but separation will increase the amount of force. Here the product is increasing the force, but the separation will decrease to compensate the magnitude, and so that these two forces will equal in magnitude and will have the net force as 0. Now we are having the third charge over here. This is q, this is minus 4q. Now we are finding the force. Of course this 2 will be equal. If it is F1, it is F1 and it is F2. So F1 should be equals to how much? F2. So that we'll have the net force. How much? It is 0. So the F1 is the force between these two. F1 is the force between, the minus q. This is minus q and this minus 4q. So the force will be, the total distance between these two will be how much? Let this separation, we have placed the charge at distance x from plus q, that is from A. So the force will be k, q and 4q, that is the 4q square divided by r plus x square is equals to, the force between these two will be k, q square, it is q and q, divided by separation between these two charges, how much it is? X square, this is cancel out, q square will cancel out, 4x square will be equal r plus x whole square. The square will be over here, the x is equals to r, 2x equals to r plus x. Okay, now this x is equals to r, so you will place x equals to r, so you will place this charge at distance x from this plus q and it will experience net force as 0. So the very simple question, students, try to see this question again by yourself. Okay, now I'm giving you another simple example so that you can solve by yourself. This is your classwork. Minus 2q and minus 8q. Separation is r. The third charge is plus q. Now you have to find the position. This is the charge A and B. Where should be this third charge Q3 placed on line joining AB so that it experiences FQ3 as 0. Find position. Okay, you have to find the position. Another question. Okay, the rest question you will find in my assignments. I'll give you assignments so that you can solve the question. There are a number of questions in my assignment, and you can solve that assignment for your practice student. Now let we move for the another type of question on the basis of the superposition principle. Now you have to find nature, position, and magnitude. All the three things you have to find: nature, position, and magnitude of third charge, so that system of charges remain in equilibrium. What is the meaning of equilibrium? Equilibrium means all the three charges, if I put here Q, here minus 4Q, and the third charge, we don't have any concept of this third charge, whether this is positive, negative, and what is the magnitude of this third charge. But the question is asking, the separation is R, the question is asking where should be third charge Q3 placed so that the system remain in equilibrium. Okay, how will you solve this question? I was asking what is the meaning of equilibrium. Equilibrium means if you are putting this Q3, so it is not necessarily only that Q3 experiences net force 0. Actually, equilibrium means all the particle or all the bodies of this system experiences net force 0. If we place this Q3 in between these two charges, it means this Q3 will experience 0 force, Q will also experience 0 force, and minus 4Q should also experience 0 force. So how will you solve this question? Remember, you have to find nature, position, and magnitude, all the three things. Okay. Now try to solve this question. First, we'll try to find out the nature of charge. Where should be this third charge and what should be the nature of this charge? Okay, one by one, we are having three positions. Out of this Q, beyond this Q, between Q and 4Q, and beyond 4Q, minus 4Q. First, we put here Q3 and suppose it is positive. Okay, if this is positive, if this charge is positive, of course this is positive, then what will happen? This positive and positive repel, this positive and negative attract, so the net force might be 0. Very good. Now here third charge experiences net force 0. Now over this one, this plus and this plus, what will happen? It will move in this direction, and this plus and this minus, what will happen? This will attract towards this minus 4Q. So both the forces will be in same direction, and it will experience a net force. So the system is not in equilibrium, so it cannot be taken as positive. Now put here negative charge out of this charge Q, that is beyond Q. Minus plus, it will attract, this minus plus repel. Very good. Net force 0. Now over this one, try to find out the force, net force over this one. This is plus, this is minus, attract, this is plus and this is minus, it will attract. Very good. So this is also in equilibrium. Now over this one, this is minus, this is plus, it will attract, this is minus and this is minus, it will repel. Very good. So we can put negative charge over here. So for negative charge, we tested and we find, okay, it can be placed out of, that is beyond Q. Now we'll put this negative charge in between these two charges. As we have discussed earlier in previous question, if these two charges are opposite in nature, so we cannot place any charge plus or minus in between these two charges. So it will be the wastage of time if we will try to find out the net force over any charge. Now put this negative charge out of this 4q. We have also discussed whatever may be the nature of charge, but we have to place the charge near the smaller magnitude. Here the smaller magnitude, so we cannot place negative charge over here, because negative will only give you the nature of force, but the magnitude will be enormously very high, so will not have the net force 0. So we cannot place the negative or positive charge over here also. It means we are only and only having one probability to put negative charge over here. So this one is the tested and okay. So we find the nature. The nature is negative. I hope you understand. If you're not getting, try to see the video again and again by moving back. Okay. Nature will be negative. Now try to find out the position. Second, position. And position, already we have discussed how to find the position. If this distance is x, we'll get that position x will be r. We have solved already this question, so we are having position also. Now magnitude. How will find the magnitude of the third charge so that the system remain in equilibrium? So to find the magnitude, remember students, if you are finding the force on this one only, that is the Q3, suppose any charge Q3 as Q, okay, small q, this is the small q. If you are finding the net force over this one, so Q will appear in both the equation between this two and between this two, and Q will be cancelled out. So you cannot find out the value of Q. So you have to find the net force on either this plus Q or this minus 4Q. So find out the net force over this one, okay, over this one. F net will be how much? Since system is in equilibrium, so the F net will be 0. F net 0. Now between these two, the force, we can write here the K, Q divided by x square, and x equals to how much? It is R, equals to between these two, K, Q, 4Q divided by distance how much? That is R square. Cancel out, K will be cancel out, Q will be cancel out, R square also cancel out. So this Q is equals to 4Q. Now we are having the answer. Okay. Now I am giving you the next question, and try to solve this question by yourself as a classwork. You have two charges, minus 2 coulomb, minus 8 coulomb, sorry 8Q, minus 2Q and minus 8Q. Separation is R, and the third charge Q3. Okay, you have to find three things. What? Nature, position, and magnitude. Nature of Q3, position of Q3, and magnitude of Q3, so that system remain in equilibrium. Okay, system remain in equilibrium. Try to solve this question, and The number of questions, I'm not giving you the more questions. Number of questions are mentioned in my assignment that you can solve by yourself. Okay. Now we'll move for the next type of question. Now another kind of question you can solve on the basis of the superposition principle and Coulomb's law. Suppose this is a question of your board level. Here the two pitch balls are suspended with a thread of length L. The masses are M and charged by Q. If we charge this two pitch ball with the equal amount, the question is you have to find the tension. Find the tension in a string. Find the tension in a string at an angle theta. I will generalize this question. In this question, I am asking the angle theta even, tension, even the question will be given at certain angle, you have to find the tension, or for certain tension, you have to find the angle. Okay. So, how you will solve such type of question? There will be the last variation in this type of question. First, try to understand the mechanism of this question. If we have two pitch ball and we'll leave this pitch ball, what will happen? Both are identically charged in nature. Q and Q, and the mass also, they will separate by some distance. Okay. Let the angle is theta. All right. Of course, this ball is moving. There must be some tension in a string. Let it is T. Why this two balls separated? Because both are identical in nature. Which force will be there? Of course, electrostatic force. Electrostatic force. And due to masses, there must be gravitational force also. Remember, we discussed earlier the gravitational force will be very small in comparison to the electrostatic force, but we have discussed that gravitational force for the very small charge, that is the electron and proton. This is the pitch ball having the very much larger mass than the electron and proton. So we'll discuss and we'll consider the gravitational force. How much it is? mg. Here m times g. Okay. Now, if this is angle theta, so this is also theta. Try to get free body diagram. This is mg. This is electrostatic force, the tension T, and this is the theta. Tension T will have two components. Here the T sine theta and T cos theta. Okay. Now, you can find the separation also, since the length of the string is given as L. So, this distance will be how much? It is L sine theta, L sine theta, and this is also L sine theta. So, the total distance will be, if you write here the R as how much? 2L sine theta. Okay, very good. 2L sine theta. Now, F can be written the k q square, sorry, to the small q square divided by r square. How much? 2l sine theta whole square. And this mg will be equal to how much? T cos theta. And f will be equal, that is kq square by 4l square sine square theta will be equal t sine theta. Okay, this is the equation 2. Now dividing this two equation 1 and 2, this two equation 1 and 2 you will divide, and you will have this 2 divided by 1, t sine theta by cos theta, that is the tan theta. Okay, and the t cancel out, and you can find here the kq square over 4l square sine square theta divided by mg. So you have a general expression. Here you can correlate this all the value, and sine theta can be calculated with the help of this tan theta also, and you can find the relation between this theta and L. You have to find out the tension. So the tension, you can find the tension by this equation 1 or 2. If you're not having the theta, then you can find out the cos theta from this equation, and you can put the cos theta to find here the tension. The T equals to mg by cos theta. Okay, mg by cos theta. So the cos theta you can find out from this equation and put over here to find the tension. Okay, actually the question was asking to find the tension for given theta. So if the theta is given, then it would be very simple to find the tension. But if theta is not given, only length is given and charge mass given, then you can find the theta over here. From here you will solve this equation to find the cos theta, or might be the sin theta you will get, and then you can calculate value of the cos theta and you will put, and you will find the tension. You can find the tension from this equation also. Okay, equation 2. So in this way you can solve this type of question. This question has been asked in board examination. The number of question I can give you in this way that are from competition corner. Okay, you will get more interesting question like this one in my assignment. So this is all about today's lecture 5. Thank you, students.